Welcome to Next Gen Tech, Talent and Trends by Sequoia Connect, the space where we explore, with clarity and purpose, the real impact of talent, technology, and artificial intelligence on organizations.
We are Silva, and today we invite you to reflect with us on the decisions shaping the present and future of the IT industry.
Here, we don't just discuss headhunting, AI, or tech consulting.
We discuss what truly drives people, the need to grow, adapt, and lead.
This deep dive is for you if you're ready to take control of your career, lead change, or learn something new.
Let's get started.
Okay, so for today's deep dive, we're jumping into a huge topic: the transformation of software engineering roles.
It's a massive shift, and our source material gives us a really fantastic way in. It's this story.
Right, a story about a character named David. He's a director of engineering.
And he's described as, usually the calmest person in the room, the anchor.
The one you want around during a fire drill. But now he's feeling this immense, almost paralyzing pressure.
And what's interesting is where that pressure is coming from. It's not actually from inside his own team. It's not a technical failure.
No, it's external. It's from his peers.
Exactly. He's on platforms like LinkedIn, and he's just seeing this constant stream of his peers bragging.
Bragging about what, specifically?
Record shipping velocity. That's the big one. And fully AI-integrated workflows.
So it's this public competitive pressure. It's not just noise. It's like a new standard is being set in public, in real time.
Mm-hmm. And if David's team is seen as being, say, half the speed of everyone else's, that's a huge problem.
It's not just about losing market share. It's an operational deficit. He looks like he's behind the curve.
And that's really the core fear that's driving this whole discussion. David knows he has to integrate AI. He has to.
But he's frozen. And the source points to two really profound anxieties he has.
The first one is just the sheer uncertainty of the tools.
Right. It's not as simple as deciding whether or not to use GitHub Copilot anymore.
Not at all. We're talking about entire ecosystems of new agents, new IDEs. The choices are just overwhelming.
And these aren't just drop-in tools, are they?
No, that's the thing. They require you to completely rethink your CI/CD pipeline, your whole workflow.
So David's asking himself, do I go with a proprietary tool, one of these big agentic IDEs?
Right. Which might give him a speed boost, but also locks him into one vendor.
Or does he try to, stitch together his own system with open source tools?
Which gives him more control, but takes a lot more engineering effort up front.
And if he makes the wrong choice now?
It's a massive waste. He's months behind, and the investment is gone.
Okay, so that's the practical anxiety, the tool choice. But then there's the second fear, which feels more existential.
It is. It's the technical debt bomb.
He knows that if he just unleashes AI without a real plan, that velocity his peers are bragging about is going to backfire.
Massively.
Yeah.
It'll just translate into an exponential increase in technical debt.
And this is really the key insight, isn't it? This is what separates him from the leaders who are just chasing speed.
Yes. He understands the nature of the code that's being generated.
He knows it might just be mediocre.
Exactly. It might be a little repetitive, maybe it doesn't quite follow internal patterns. And if you accelerate the generation of that mediocre code by 10 times,
you haven't actually gained anything. You've just accelerated the decay of your own system.
The maintenance costs just explode. They completely overtake any production gains you thought you had.
So his absolute worst-case scenario, his nightmare, is becoming the architectural janitor.
The one who has to clean up the mess.
Right. He's imagining his team, these highly paid, brilliant engineers, spending all their time just debugging code a machine wrote.
Trying to unravel logic from an AI that didn't understand the full picture, the system's constraints.
It's a total fear of losing architectural control.
Mm-hmm. If the AI is writing code faster than his architects can review it, the whole structure of the product just vanishes.
But the source material, thankfully, doesn't just leave us there in that state of fear.
No, it offers a way out. It introduces the core thesis for this whole discussion.
Which is, the answer isn't to try and avoid this flood of AI-generated code.
Because you can't. The answer is to build a dam.
A dam of intelligent governance and orchestration around it.
Exactly. And that is the mindset shift. It's a big one.
We're no longer the code producers.
The machines do that.
Yeah.
Our value is shifting entirely. We have to become the code managers, the architects.
Okay, let's unpack that, because this leads to a really critical diagnosis in the source material. It's the foundation for everything else.
It is. It's the idea that the generation era is dead.
The generation era.
Yeah.
Meaning the time when we were all just impressed that an AI could write some code at all.
Yes. We were amazed it could write a sorting algorithm or, parse some JSON.
Yeah.
That time is completely over.
That was an era of, low expectations. We were just impressed that code appeared.
We were. But that simple generation, it's a commodity now. If your company's whole AI strategy is still just about making developers type boilerplate a little bit faster,
You're already obsolete.
you are strategically obsolete. That capability is table stakes. It's baked into everything.
So the new reality, the source says, is that we are now in the integration era.
And that word integration is so important. It completely changes the job description.
It implies systems thinking, right?
Mhm.
Complexity connecting different parts.
Not just focusing on a single file. It's a shift from optimizing the individual writer to optimizing the entire machine of software production.
And this has to have huge implications for talent, for hiring.
Oh, massive. The integration era demands engineers who can look at a problem, see the different agents required to solve it,
Right.
and then this is the key part.
Then define the governance to make sure the output is actually safe and compliant.
Precisely. By 2026, the mandate is clear. You have to be able to orchestrate agents, govern quality, and architect systems.
Can we just pause on the economic side of this for a second?
Sure.
If all those low-level repetitive tasks of the generation era are now commoditized, where does that leave the mid-level developer? They seem like the most vulnerable group here.
I think they are, unfortunately, the most exposed.
Why them specifically?
Well, think about it. The junior role is about learning standard patterns, which AI can actually help accelerate.
Okay.
The senior role is about architecture and mitigating risk, which AI augments. The mid-level role, that person whose main job was translating requirements into standard, well-written code.
That's the part the AI can do now, faster and more
Yeah.
consistently.
Exactly. So the only path forward for that developer is to level up. They have to absorb the skills of the architect.
They have to stop being just a coder and become a governor, an orchestrator.
Right, the upgrade. It's not about displacement. It's about a role change.
So for senior engineers and architects, this isn't a threat. It's actually a massive leverage point.
It's the ultimate leverage point. They are finally free from the mechanical act of typing to focus entirely on the meta skills.
Setting the guardrails, defining the workflow, ensuring the health of the system.
Yes. And their knowledge, their experience with past failures and system design is more valuable than ever.
Why more valuable?
Because the cost of making an architectural mistake when you're using AI to build at 10 times the speed is exponentially higher.
A mistake gets amplified across the entire system instantly.
Instantly. Which brings us perfectly to the 3 critical skills David and all of us need to master to survive this new era.
Okay, so let's get into the first one. Our first critical skill is context orchestration.
And this is really the fundamental shift away from simple autocomplete.
We all know autocomplete. It predicts the next line of code based on the last few lines you wrote.
Right. It's local. Orchestration, on the other hand, requires the AI to understand the full repository.
Everything. The dependencies, the documentation, the weird legacy code from 5 years ago.
Everything. The entire architectural history. And this directly addresses David's fear of the AI generating, hallucinated code.
So a standard LLM, it operates like a new junior developer, right?
That's a perfect analogy. It's fantastic at general programming principles, but it has zero project-specific knowledge.
So it might suggest, say, importing a common library from the internet.
Oblivious to the fact that your team built a custom, highly optimized version of that same utility 3 years ago, and it's buried deep in your internal library folder.
And the failure there is that the AI creates a local optimization that causes global chaos.
Exactly.
Yep.
It fixes a small bug with code that is syntactically perfect, but it fundamentally violates some unwritten, non-obvious internal pattern that everyone on the team just knows.
And the solution to this problem is a tool shift.
It is a shift towards what the source calls Agentic IDEs.
And it names a few specific examples: Cursor, Windsurf, and Google Anti-Gravity.
Right. And these aren't just fancy text editors. They are context-aware environments. They act as intelligent agents that sit on top of your entire code base.
And the key technology that makes them context-aware is RAGE.
Right. Retrieval Augmented Generation.
Can you break that down for us? What is R, really?
So in simple terms, RJAB means the IDE doesn't just rely on its general knowledge from the internet. Before it generates any code, it actively scans your project.
It reads the code, the markdown files, the API schemas.
Everything. It retrieves the most relevant, project-specific pieces of information. It's like giving the AI a super detailed, real-time instruction manual for your specific, messy code base.
So without RAG, the AI is just guessing.
It's guessing based on what it saw on the internet. With RAG, it's making an informed decision based on your unique reality.
So the skill for the engineer is no longer just writing code, it's orchestrating that context.
That's it, learning how to feed the right context to the AI, making sure that ARG pipeline is actually effective and up to date.
Okay, but let me push back on that a little bit. That sounds great in theory, but trying to implement a good ARG system on a 10-year-old legacy code base sounds like an absolute nightmare.
It's a huge challenge.
Aren't we just trading one kind of complexity for another? Swapping the complexity of writing code for the complexity of maintaining this giant knowledge base for the AI.
That is a critical point, and it's precisely why context orchestration is a senior-level skill. It's not for juniors.
The complexity moves from typing to data engineering.
Yes. You have to maintain your vector database, which is the index of your code base that the RAG system queries.
And if that index gets out of sync with the actual code?
The RAG mechanism starts to degrade, and the AI starts hallucinating again. Latency is another big problem. If the retrieval process is slow, developers just won't use it.
So the senior engineer is now managing the data pipeline that informs the prompt.
Exactly. Which requires that deep architectural knowledge because the prompts themselves become architectural.
Like the example in the source material. It's brilliant. You're not just asking for a Python function.
No. You're giving a command that's layered with architectural constraints. Something like, refactor the authentication module using our specific user interface pattern defined in types and update the dependency tree.
Wow. Okay, so to even write that prompt, the engineer needs to know at least 3 very specific things. 1, where that user interface pattern is and what it does. 2, what the authentication module actually consists of internally.
And 3, and this is the really subtle part, that the change requires updating the dependency tree, a step a naive AI would almost certainly miss.
This is why it's such a leverage point.
It's the ultimate leverage. It lets one engineer execute a task that might have taken a team 3 weeks, but it demands an engineer who thinks like an architect and writes like a technical writer.
Okay, so once you have agents generating tons of context-aware code with skill number 1,
You immediately run into the next problem,
Yeah.
which demands critical skill number 2,
which is automated governance. And this requires a new mindset.
the editor-in-chief mindset.
Because the challenge now is that this huge volume of AI-generated code, it introduces new, more insidious forms of technical debt.
Absolutely. We're way past simple syntax errors. The new debt is things like hallucinated dependencies.
Where the AI suggests importing a library that doesn't even exist, or worse, an insecure version of one.
Or subtle logic flaws that only show up in weird edge cases. And the real danger is that the code will run. It will pass basic tests.
But it will run incorrectly or insecurely under very specific conditions that AI just didn't think to model.
Right. We need a concrete example here.
Okay. Imagine an agent generates a function for financial calculations.
Mm-hmm.
It works perfectly with all the positive numbers in your test suite. But the first time a user gets a refund, a negative number goes in.
And it silently corrupts the data structure because the AI missed a basic absolute value function or an overflow check.
Something a human senior engineer would have added out of pure instinct.
That's the perfect example of a silent failure. The code works for 99% of cases, but it fails catastrophically in that 1% edge case.
And this is why the tool shift is towards things like CodeRabbit.
Yes, dedicated AI code review tools. The source says they are non-negotiable now.
They're not just linters checking for style. They're like an AI reviewer that's integrated right into your pull request process.
A mandatory quality gate. It flags logical problems, potential race conditions, violations of your architecture.
It does all of that before a human even has to look at the code.
Right. It moves the bulk of quality assurance from slow, expensive human effort to automated, machine-enforced standards.
So the mindset for the human engineer has to shift. You move from writing code to
Emphatically auditing code. You are the editor-in-chief.
your value isn't how many lines of code you can write. It's how quickly you can audit 10,000 lines generated by a machine and find the one systemic flaw.
Exactly.
But again, let me play devil's advocate. Isn't the senior engineer now just spending all their time configuring CodeRabbit and writing these complex governance rules?
That's a fair point.
Aren't we just swapping one bottleneck, slow typing, for another slow governance configuration?
It's a different kind of work. But the key difference is scalability.
How so?
A human engineer can only review so many lines of code in a day. It's a hard limit. If AI is generating code 10 times faster, human review becomes the bottleneck, guaranteed.
Okay.
Automated governance, on the other hand, scales the human's judgment. It scales their knowledge across the entire code base instantly.
So the human provides the wisdom, but they express that wisdom by configuring rules, not by typing code.
Precisely. Only a senior engineer who knows from painful experience that the old V1 caching layer causes deadlocks can configure the tool to say, flag any PR that even tries to call the V1 caching API.
The junior dev or the AI can generate the code.
But only the senior configures the rules to catch those silent failures.
And these tools check for more than just style, right? We're not talking about tabs versus spaces.
Oh, far more. They check for things like cyclomatic complexity, basically. So many different paths there are through a piece of code.
If it's too high, the code is too dense and impossible to maintain.
They check for internal API adherence. Is the code talking to the database the right way, or did the AI hallucinate a shortcut?
And crucially, domain-specific security patterns.
Yes. If you're a bank, it checks for your specific rounding rules. If you're in healthcare, it checks for how you handle PII. That all has to be configured by a human who has that institutional knowledge.
Which really brings home that reality check from the source. You have to be able to read code faster than you can write it.
If you can't scale your oversight, you can't scale your output. End of story.
Okay, that brings us to the third and final critical skill. This one feels the most abstract, the most strategic.
It is. This is agentic workflow integration.
And this is where we move completely out of the code and into system design. This is the architect title in action.
You're no longer just designing the feature. You're designing the pipeline that builds the feature.
It's the highest level of abstraction. We're moving beyond fixing the code or governing the code.
And into fixing the organizational process that creates the code in the first place.
So the scope shifts from task execution, just writing code for a ticket,
to workflow design, connecting a high-level business goal directly to a chain of specialized AI agents.
And the main goal here is just radical friction elimination.
Exactly. We're targeting that painful gap between a business leader saying, I have an idea, and that idea becoming an actual technical ticket ready for an engineer to work on.
That whole middle ground of meetings, spec documents, refinement.
And human interpretation, which is where the telephone game happens.
Yes. Where the requirements get corrupted and lost as they're passed down from person to person.
The business person speaks in revenue, the product owner speaks in features, the project manager in velocity, and the developer in code. By the end, the original intent is gone.
So the tool shift here is targeting that loss of fidelity. The source mentions platforms like linear integrating AI agents for triage.
Yes. So imagine you have a 2-hour product meeting. It's messy. The transcript is full of vague ideas and conflicting requests.
The triage agent can take that unstructured mess
and perform that first critical layer of translation. It turns the conversation into structured, atomic, actionable tickets. It even estimates priority.
all without a human having to manually create dozens of tickets.
Right. But that brings us to the key human skill here, strategic translation. This is the architect's new superpower.
So the architect takes the output from that triage agent and performs a second, even more critical translation.
Yes. They take a high-level business request like, we need to improve user retention in the onboarding flow.
And they transform it into atomic technical commands for the other agents.
It's a complex process. Improved retention might get broken down into. Task 1, increase database query timeout for the user profile agent. Task 2, refactor the splash screen to use dynamic content. Task 3, write 5 A/B tests for button colors.
So the architect is the chief communication officer. They're the API between the business and the technical execution agents.
So they're the only one who can write that technical map that aligns the business goal with the how, the technical implementation.
The return on investment there must be huge. You're eliminating all that requirement corruption.
Staggering. You ensure the original business intent flows cleanly all the way down to the specific instructions you feed into your Agentic IDE.
So the architect's job shifts from solving technical problems to defining technical problems that agents can then go and solve.
That's the highest leverage point in the entire system.
So we have to circle back to David's initial hesitation because the source material is very clear about this warning.
He was right to be afraid of his peers just chasing velocity.
The core warning is velocity without governance is just accelerated technical debt.
And this is the trap. This is why so many companies apparently failed in their first attempts at AI adoption back in 2025.
Their big mistake was laying off their senior engineers.
Yes, this incredibly naive belief that AI could replace their ability to understand consequences.
AI is great at execution, but it's terrible at foresight.
Exactly. And we should get specific about the risks here because these are the dangers the three skills are designed to prevent.
Okay, first one, security hallucinations. What does that actually look like in practice?
It happens in a couple of critical ways. First, the AI, trying to be helpful, might import a package that doesn't exist in your private system. Or worse, a deprecated, insecure version of a library it saw in its training data.
So it might pull in an old version of a library that has a known vulnerability.
Right. The LLM's goal is just to produce plausible code that works, not necessarily secure code that's compliant with your standards.
And the second way is subtler.
Much subtler. The AI might write a function that works but completely forgets basic security, like sanitizing user input or handling errors correctly.
And a normal linter might not even catch that.
Often won't. Because it's not a syntax problem, it's a logic problem. It takes a specialized governance tool. Skill number 2, configured by a human who knows the common attack vectors to flag that kind of mistake.
Without that, high velocity just means high vulnerability.
Precisely.
And the second big risk, which seems even scarier, is logic drift.
This is what creates the Frankenstein code base the source warns about. It's not one big failure. It's a slow, systemic corruption over time.
How does it happen?
It happens when different AI agents, responding to different prompts over months, all optimize for their own local task without any regard for the overall architectural vision.
So an example would be, an organization starts with a strict microservices architecture. Everything is stateless.
Exactly. But over 6 months, various agents get prompted to just get this data quickly or add this feature fast.
And the agent, trying to be efficient, might introduce a stateful variable into a stateless service.
Or it might create a direct database connection where it was supposed to use an abstraction layer. Each change is small and seems harmless on its own.
But over time, the code base drifts further and further from the original blueprints.
And then, when you need to do a major upgrade or a new senior engineer tries to join the team, they find a system that's completely unmaintainable. The complexity wasn't removed. It was just hidden in layers of AI-generated quick fixes.
So those three skills we talked about, orchestration, governance, and integration, they aren't just about efficiency.
Not at all. They are mandatory safeguards. They are the dam David needs to build to make sure his velocity is healthy and sustainable.
Okay, so if you're a leader like David or an engineer listening to this, the message isn't that you're becoming obsolete. It's that you're being forced to upgrade.
You're upgrading your own operating system. And the source is really clear. Don't just jump straight to full AI autonomy. That's a huge mistake.
You can't just hand over the keys. You need a staged evolution.
Right, a roadmap. And it recommends a 3-phase approach.
What's phase 1?
Stabilize. This is about building trust and getting quick wins. You start with basic AI tools like an enhanced Copilot for very defined low-risk tasks.
Like writing boilerplate code, generating documentation, clearing out the backlog of simple bugs.
Exactly. You do it on non-critical services. You're just trying to prove the tech works for repetitive stuff and establish a baseline of trust.
And once you've got that initial speed boost, you have to move to phase 2.
Immediately. Govern. This is where you build the dam. You implement those AI-native CI/CD pipelines and the sophisticated governance tools, like CodeRabbit.
So having increased your speed, you now have to make sure that speed isn't creating chaos.
You're setting up automated vigilance.
Right.
Every single piece of code, whether it's from a human or a machine, now goes through that high-fidelity audit before it ever gets to the main branch.
And only then, when governance is solid, do you move to phase 3.
Which is orchestrate. This is the senior level move. This is when you put your best engineers into those agentic IDEs, the cursors, the anti-gravities, and let them start tackling the big, complex architectural problems.
So instead of a senior dev spending 10 days writing a complex migration script,
they spend 2 days writing a very precise, context-aware prompt that lets an agent refactor the entire system and update hundreds of files at once.
Yeah.
You're multiplying the impact of your best people.
But this roadmap brings up what might be the biggest challenge of all, building the hybrid team.
It's a massive human capital problem, a huge culture clash waiting to happen.
You have your domain experts, the veterans who built the legacy system and know where all the bodies are buried.
And they hold all the critical context for skill 1 and the governance wisdom for skill 2, but they might resist the new tools.
And on the other side, you have the new talent. They're fluent in prompting and agentic workflows for skill 3.
But they lack that deep institutional knowledge to spot a logic drift problem before it's too late.
The source says you might need to inject new DNA to bridge that gap.
Which could mean strategic hires,
Yeah.
people who are both architects and agent experts, or it means a serious, deep investment in retraining your existing staff.
And not just retraining on the tools, but on the whole mindset shift.
Exactly. David's biggest test isn't buying the right software. It's managing this human transition.
Which really brings us to the final conclusion for anyone listening.
The developers who are going to win in 2026 won't be the fastest typists.
They'll be the ones who can orchestrate the agents
That govern the quality.
and integrate the systems. That's the new definition of leadership in engineering.
This has been a really intensive look at this shift, from the generation era to the integration era.
It has. And the market is moving so fast that while this source gives us a great framework, collective insight is really what's needed.
For sure. So we want to leave you, the listener, with some powerful questions to think about. These are the critical decisions that leaders and engineers are facing right now.
These are the questions David has to answer for his team.
Let's start with the tool stack. Where are you on this adoption curve?
Are you still just using standard line-by-line autocomplete, or have you actually migrated to one of these full-blown agentic IDEs like Cursor or Windsurf?
It's a huge investment to migrate, but the potential payoff in context-aware refactoring is system-changing.
Next, think about the human side, the distinct roles. If you had to recommend just one tool for a junior developer starting today and one for a senior architect, what would they be?
And why? The junior needs accelerated learning and guardrails. The architect needs maximum oversight and strategic capacity. They're totally different needs.
Then there are the challenges on the ground. For those of you who have already started this journey, what's been the biggest friction point?
Is it the technical side of context orchestration, just getting RAG to work on a messy old code base? Or is it bureaucratic, like getting security permissions for these new tools?
Or is it just the complexity of configuring the governance tools themselves?
And finally, the pitfalls. Where have you personally seen AI fail most spectacularly in your workflow?
Not just in theory, but the real-world consequences. Did you have one of those security hallucinations where an insecure package got pulled in and nobody noticed?
Or did you spend days debugging a logic drift problem because the code was technically correct but contextually, architecturally wrong? Knowing where it breaks is how we build better safeguards.
This was Next Gen Tech, Talent and Trends.
Thank you for joining us in this conversation where knowledge becomes direction.
I hope this deep dive offered you a useful pause, a boost of inspiration, or even a starting point for what's ahead as you navigate the integration era.
We hope to have left you with ideas, questions, and, most importantly, the drive to keep building your path in the world of technology and talent.
Leave us a comment, share this with your team, and help us keep growing the conversation.
Follow us on social media at Sequoia Connect, and remember, the future doesn't just happen. It's built with talent, technology, and purpose.
We are Silva, and we'll catch you in the next episode.